All right, good morning, everybody. Hope your week has been good so far. We are continuing with our discussion on fractions. Specifically, we have to do more examples about subtraction. Let's have a look. Whoopsie. My mouse doesn't want to work with me. All right. If you recall, we have started exercise 14.6, but correct me if I'm wrong, I think we've done only the first one. So let's do at least two more. One to just remember, and one that has a mixed number in it. Okay, let's get ready here. Okay, so exercise 14.6. Let's do number 2. I don't know which one we've done. I'm pretty sure we just did number 1. Okay, so we are doing subtraction, which means I still start with my first quantity, which is what I have. So let's maybe write that down. And then draw it. It's just one rectangle, portion of a rectangle. Well, I have to break it up into 6 pieces. I'll start vertical. So 1, and then each half into 3. Try to make them as equal as you can. Like so. And we have 5 of them. Not bad, it's something to work with. It's a good portion of this rectangle. Now, as I said before, when it comes to subtraction, I don't represent this other number separately. The subtraction I feel is easier on this intuitive basic level when I see it as an instruction. And the instruction said to remove some of what I have. So let's write that down. We need to take away or remove 1/4 of a rectangle, of a whole. We'll emphasize the whole here. Rectangle. There's nothing after the fraction. It's in reference to a whole rectangle for these situations at least. But I then have to figure out, well, what is that? So I go horizontal and break it into 4 pieces to get an idea of how much of the rectangle I need to take away. So let's get some lines here and break it up into 4 pieces. Half and then half again. Just fix my line here. There we go. Now, when it comes to the sentence that I have so far, this 1/4 of a whole rectangle, it's got nothing to do temporarily with the pink. Yes, the instructions are to take stuff away from what I have, but first I have to figure out how much do I have to take away. So I don't look at the pink right now. 1/4 is 1 row out of 4, so that means it's 1, 2, 3, 4, 5, 6 pieces. 6 square pieces. Now I look at my instructions. And I see, oh, I have to take this away from the pink that I have. So let's write that down maybe. Need to take away 6 pink ones according to the instructions. So, well, we have how many pink ones? We have 4 rows, 1, 2, 3, 4, 5 in a row. So we have 20 pink pieces. So that means we're left with obviously 14 pink pieces. Now you can add sentences here. Don't take too much away. People tend to want to write as little as possible. And then they're shocked when I don't understand their reasoning and their explanation. You need words to explain stuff. Whatever it is, explanation means words. Use words and enough words to have any reader understand and follow how you're using this. I have to look objectively at what you're writing down without guessing, pretending I've never done this before. I'm just going on what we write. So there has to be enough to go from one line to the next and have it make sense. No big jumps in understanding or reasoning. So I have 14 left. So 14 pink pieces, that is my answer. But I need to now represent this in reference to a whole rectangle. So I have my standard sentence. It takes, how many do I have here? It's 24 pieces in general to fill or make a whole rectangle. Therefore, so we have left 14 over 24, 14 24ths. And of course, that's in reference to a whole rectangle. If you feel the need to simplify that, do it after the 14 over 24. Simplification is not a part of this. It's not a part of this model. It's not a part of this process. It's an optional thing you want to do if you want to keep yourself busy. But I have no purpose. I have no reason to simplify this answer. Nor does, 7 over 12 doesn't come out of this. There's no 7 here. There's no 12 here. So if you write your answer as 7 over 12 before 14 over 24, then really I don't know if you understand this, because there are no 7s here. There are no 12s in this process. This is not, simplification is not a part of this. So I would prefer that you don't simplify, because it's not clear if you then understand what we're doing here. All right, that is number 2. If I sound a little bit strange, I apologize. Not feeling that great, but I'm hopeful that doing some fractions will make me feel way better. There's really no other way, is there? Let's do number 4. Just so that I have some mixed numbers. Whoops, that's not it. 2 and 2/3, that's it. Minus 1 and 7/8. We haven't done eighths yet, so let's do 1. So I have some mixed numbers. Just like in the case of addition, we saw, okay, we just want to be prepared. What if there are mixed numbers? Is there a major adjustment? Yes, no? Let's find out. So I have a little bit more. So I just want to have some space. I'm going to have 3 rectangles here. Whoa, not like that. Trying to make them as equal as possible because they technically are identical. And then I need to break up the last one into 3 because I don't have a full 3 rectangles. I do, however, have a full 2. So at this stage, there is no need that I can see to break this up and have a lot of lines here and have it look all messy. Just like for addition, we had no need to break these up. And I have 2 of these 3 slices. All right, sounds good. That's what I have. Then I need to take away some stuff. Let's write that down first. Need to take away 1 7/8. Let's write that, expand that a little bit. 1 whole and 7/8 of a whole rectangle. So the 1 whole, let's make it red. Maybe not red, maybe blue. Red and pink look too similar. So if I want to take away the 1 whole, I can just take away 1 whole rectangle that is pink already. But when it comes to the 7/8, I don't know how much of the pink I need to remove. The 1 whole was straightforward, the 7/8 is not. So just like before, I need to see here a little bit. What is this? What is this? For that reason, I'm just going to take a rectangle and split it up into 8 pieces horizontally because I've done vertically already. Now 8, I don't want to go too high with denominators. 8 is perfectly fine. So do practice 8, but don't go above 10. Let's go here, and then I split the half in half. And then I split each of those in half. So it gets a little thin, which is why we don't want to do denominators that are too big, then this falls apart. You can clearly see that. This diagram method isn't going to work for much longer if my numbers get bigger in the numerator or denominator. So there's a shelf life on this guy. We're not going to be able to do this for very long, so don't worry about going above 10. So when I look at a whole rectangle, this one for example, 7/8 mean I need to look at 7 of the 8 rows. Each row has 3 pieces, so I have 21 of these thin little pieces. Just sort of as a side note. I could do something with the whole already, remove that, but I still have to remove 21 pieces. Now you see over here, how many pieces do I have? I have 1, 2, 3, 4, 5, 6, 7, 8. I have 16 pieces that are pink. So I can think ahead a little bit and say, oh, I need to take away 21. Don't have enough. I'm going to have to dip into this middle whole rectangle. I need to remove some of that as well. So for that reason, I need to break this guy up as well. I didn't know that until now. Maybe I didn't have to break him up. But in this case, because I have to remove so many, I'm going to have to cut into this middle loaf of bread. So let's do that. So I split it up in exactly the same way. 3 pieces vertically, 8 pieces horizontally, half is cut in half, is cut in half, half of a half of a half is 8, or is an eighth. Alrighty, there we go. but understand why I needed to do this. I wasn't going to do it just for the sake of it. There's no need for that. I have to do it because I need to remove more than the pieces that I have in this last one. If for some reason the fraction wasn't that big, I only had to remove 16 or something else, 12 maybe, then I didn't have to break up this middle one. I have enough already. So now I have to remove. Let's do that. So what you could do as an option is you could actually start crossing them out for little Timmy. Okay, I need to cross out 21 of them. 1, 2, 3, 4, 5, 6, 7, 8. Now, what seems tedious to you might be very helpful for little Timmy. And give him some time to systematically understand this taking away process. Count them off. Know your audience. We maybe have the flexibility to maybe just do a subtraction, count all these pieces. I have 5 columns of 8, so I have 40, and I can just do 40 minus 21. But for little Timmy, that might not be what he's ready for. You have to adjust according to your audience. So I crossed out 16 so far, 17, 18, 19, 20, 21. And then we can count how many do I have left. Well, 1, 2, 3, 4, 5, 6, 7, 8, 16, 17, 18, 19. So there are different ways to get to that 19 pieces that are left. So because we've demonstrated here, we don't need that sentence, I think. We have left, whoopsie, not pink. Ooh, that's a nice color. We are left with, what did I say? 19. 19 pink pieces. Now I still have the problem of rewriting this in its corresponding fraction form, referencing a whole rectangle. So I have my standard sentence. It takes 24 pieces to make a whole rectangle. Count them off if Timmy needs to do that. If Timmy after a while starts to notice, oh, it's always the denominators multiplied together. That's for him to discover, not for me to force on him. There's something very effective about just slowly counting and letting the discovery take place. You can't know how much time that other person needs. It takes 24, so we are left with 19 24ths of a whole rectangle. Luckily in this case, you can simplify it even if you want to, so haha, I don't want to simplify anyway. And there we go. Subtraction, different on the basic intuitive level for sure, but it's very much on the same level as addition in terms of difficulty. Okay, good times, I hope. Let's make a new page and move on to the next one. We are just going to take as long as we take for multiplication and division. They are definitely more complicated. And as such, we have to be careful about how we're going to present this so that every step makes sense as much as it can. When it comes to multiplication, we do need something first. Multiplication. I do need to get my words that are that fit with this concept. Now, most people, by the time they get to school, they've had some exposure to uh, fractions, even if it's just a half. So take a half, uh, if that's the only familiar fraction. If I say, uh, let's say we have some instructions. I give an instruction, and that instruction is, um, I'm hesitant to use the word take because we use take away with subtraction, but I'm going to take uh, 1/2 of, let's say, 4 pencils. I put 4 pencils on the table in front of little Timmy. I give him the instructions, take a half of what you see. There's no doubt he's going to then take 2 of the pencils. So when I make the fraction as easy, as intuitive and familiar as it can be, I think a half is probably the easiest of all fractions. What we're doing is not difficult to intuitively understand what the instruction is asking. Now the corresponding calculation to take a half and 4 and give me a 2 is, of course, a half times 4 equals 2. So this means that this multiplication operation has a key word that helps me intuitively understand what the instructions are. And that key word is of. Take a half of something. Of is the key word. That, in my experience at least, when you use that word, knowing what to do is much more obvious. That if I say, take a portion of something, everyone's going to know what to do. Okay, just what portion do I have to take? And the calculation that is behind that is the multiplication. Now, this only works when I have a small fraction at the start here. So here, I need to have a fraction less than 1, because I'm only taking a portion of some quantity. Okay, but this second number can be any number. It can be any number because it can be any quantity. Okay, so when I read a multiplication like this, and I now have to intuitively figure out what to do, I think of the of word, and the instructions are telling me I have 4 pencils. This is what we have. I have 4 things. Take a portion of that. So the second number in the multiplication is the quantity that I have, contrary to what we've seen before. I now have to remember that if I want to intuitively interpret a multiplication calculation, the second number represents the quantity that I have at the beginning. Why? Because of this. Take simple numbers that Timmy will intuitively understand what to do. And in demonstrating this instruction, you start with 4 pencils on the table and then take a portion of that. So the second number is the number that we start with. So now let's see, when we get to fractions, how are we going to structure this? How are we going to lay this out so that it presents well? So let's take 1/5 times 2/3. Just start with both proper fractions. So now we know the second of these is what I have. So let's represent that. I'm going to give myself a little bit of space in front of it, like so. Now again, I want to represent 2/3, right? So I'm going to break it up horizontally into 3 pieces. That's not very good. It's better. And I have 2 of them. 2 of the 3 pieces is what I am starting with. All right. That's what I have. I have the pink stuff. Now the instructions say, take a portion of that. So this 1/5 is now followed by another fraction. It's not in reference to a whole rectangle. It's in reference to the pink that I have. So I need to take. Now, if you want to use another word than take here to have it be more distinguishable when I think about subtraction, feel free. I can't think of a nice intuitive word to use here, but it shouldn't be mixed up with, oh, this is take as well, so this is another version of subtraction. No, no, it's not. I need to take 1/5 of, I'm going to write it in pink, what we have. In multiplication, the first fraction is applied to what I have. All right. So now, how do I know how much I need to take? I'm going to go 5 rows horizontally again. That's my answer for everything. So let's do it here as well. So 5 is a little off center. I try and make them as equal as I can. So this 1/5 means 1 out of 5 rows. In my case, I made rows. So that means I might as well take the top one, and only 1 of the 5 rows I have available. It doesn't matter which one. They're all identical. So what do we then take? Or get, or whatever. Let's use get maybe. We get to keep 2 pink pieces. And it's important here that you make them pink. This guy over here, he was never something I had. So I can't take this one. I only take 2 because those are the only ones that are pink. All right. Now, just like before, my answer is going to be a fraction in reference to a whole rectangle. Standard sentence. It takes 15 pieces to make a whole. So we get or took or whatever, or I don't want to say left with. No, I don't want to do that. 2/15 of a whole rectangle. I'll write that down. Of a whole rectangle. Different? Yes, for sure. And our goal here is to make it as intuitive as possible in the sense that you don't need any other knowledge, any other trick, any other property, anything else to be able to figure out the answer as much as we can. We do need to understand the instruction in words, of course, because we're doing an explanation in words. So we do need to understand that the instructions here are take a portion of something. So then I represent the something, figure out how much I need to take of that something, take it. That's what I walk away with. I take it, walk away. And then I just want to figure out, okay, how much of a rectangle did I walk away with? 2/15. Okay. And that's multiplication. Multiplication, I think, is a step up, and it's unfortunately going to get worse. So it's very important that you understand these first ones perfectly. Otherwise, what's coming up probably tomorrow will not be so much fun. So let me just see my time here. 18 minutes. Yeah, I want to do number 2. We'll just do these as far as we can. If we get to all 3, great. But if we just do 2 of them, that's okay. So I have my fraction multiplication. That means I start with the second quantity. Happens to not be a lot. That doesn't matter. I still represent it. 4 vertical slices. Half of a half. Like so. Let's color it. Pink. Why not pink? I don't have a lot. That's all I have, unfortunately. Now the instructions now say we need to take, or we get a portion of that. Let's say here, we get 5/6 of what we have. Only of what we have. This fraction is followed by another fraction. It's in reference to that fraction. It's applied to that second one, not applied to a whole rectangle. So I need to make 6 rows so that I can take 5 of 6 rows. Because I've used columns, it's going to have to be rows. 5 of 6 rows. Let's make the rows. Cut it in half. And then into 3 each half. The bottom ones look a little bigger. Whoops. Just squint. They're supposed to look the same, of course. It's not always that easy. So 5 of the 6 rows. Okay, good. 1, 2, 3, 4, 5. Not that one. I just go from the top. It doesn't matter. So it's a lot of rows we can keep, but it's not a lot of pink. I only get to keep what I have. Oh, choose from what I have, which is 1, 2, 3, 4, 5. So we get, maybe get's a nicer word, 5 pink pieces. I didn't have much to start with. I take a large portion of them, but it wasn't a lot. Now my standard sentence to figure out how much of a whole rectangle is this that I'm getting. It takes 24 pieces in general to make a whole rectangle. So we got 5/24 of a whole. Once you get the hang of it, it's just really quite straightforward. But there was a new instruction that we have to, of course, get used to. And on the far left, basic, intuitive side, we can't rely on anything else. Anything else. Alrighty. Let's do one more. Let me just think what I want to do. I forgot to talk about properties, but I think maybe we can do properties at the very end. I don't want to mix them here. The whole point is to not use mathematical properties to find the answer. So we're going to do those at the end by illustrating, okay, after we've done addition, after we've done subtraction enough times, eventually we want little Timmy to start noticing a pattern and see those properties and discover those properties that he can eventually use when the numbers get uh, uncomfortably big. We can use this method to discover those. Same for multiplication. But when we do this, at this stage, we don't have those properties. We have not discovered them yet. So let us do number 3. Now, as I've said here, for now, we have to look at the other side of the multiplication. There's good news and bad news. The good news is that multiplication is not that hard. Take a portion of something. I feel that's fairly intuitive. The bad news is there are two sides to multiplication, and it all depends on what this first fraction looks like. Right now, we are restricting ourselves to taking a fraction or looking at a fraction first that is less than 1. It's a proper fraction. Don't make the second number a mixed number. Sorry, don't make the first number a mixed number yet. That's a slightly different intuitive story instruction. But the second one can be anything. That's simply what I have to start with. So let's look at 2 1/4. That's quite a bit. So for now, that first number is going to be a proper fraction. We're going to have to wait until tomorrow to see what happens when I make the first one a mixed number as well. Can't do everything at once. So just like before, I have 2 whole rectangles and I need to split up the last one. I don't have any need to split up the first 2 yet. Why would I? I'm not going to make lines just because I want to. I have no need. I have the whole loaf of bread. I'm not cutting into it until there is a very good reason to do so. So I have the whole second one as well, and then a little slice of the last one. I have a lot. Nice. Now my instructions say take a portion of that. So we get to take, or whatever keyword you want to use here, we get 2/3 of what we have. Let the color help you. What we have. Now 2/3 can be interpreted as 2 of 3 rows. So for that reason, I have to split everything up into 3 rows because I need to take from all the pink. So let's do it. It's 1, 2, and 3. All right. So let's do that. I get 2 of the 3 rows of pink. 1, 2, not that last one. So I get to keep quite a bit. It's not bad. However, not all the pink pieces look the same. For that reason, I do need to split up everything vertically as well. Now I understand why I need to do that, though. I didn't at the beginning. Now I have a reason to do that. I'm not going to do anything just for the sake of it. There has to be a reason. So now they all look the same. Okay, that helps. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and another 9. So we get not 9, 18. We get 18 of these squarish pink pieces. That's quite a bit. It's not bad. I just now need to put that in reference to a whole rectangle. It takes my standard sentence. It's going to be 12 pieces only. I can count them off, whatever. It takes 12 pieces to make a whole rectangle. We got to keep 18. Very nice. So we get one whole rectangle, or enough for one whole rectangle. I can put my pieces back and, like a puzzle, make a whole loaf of bread. And another 6 pieces. Of course, they're all pink. Maybe let's make them pink. That's pink. That's pink. Everything's pink. We only take from the pink. Right? Because, oh, excuse me. I got a little emotional about getting so much bread. It's so beautiful. I'm so hungry. I get enough to make a whole loaf of bread and still have 6 left over. So, finally, we get or got or whatever 1 and 6/12, because 12 is my standard amount that corresponds to a whole rectangle, one whole one, and another 6. Now again here, I'm not going to break that into a half. Where do you see 1 and 2? No, I see 6 and 12. That's what I see. And it's people's obsession with simplification that's going to confuse little Timmy. He doesn't see a half. Simplification is not important here at all. I really can go on a rant for probably an hour about how people are conditioned to simplify everything they see, and it is, what's the word? Well, it's kind of stupid because it's misguided. It's not the point. Just because I can do something doesn't mean I should do it every single time. There's nothing wrong with this fraction. 6/12 is a perfectly good fraction. I'm not going to discriminate against fractions. It's not nice. There's nothing wrong with this fraction. I do not want to see a simplified answer here. That is not the point. And then I have to question, if you simplify this, I have to question, do you really understand what we're doing here? Do you understand the point of what the question was asking? Because if you simplify, I don't know if you do, because that wasn't the question. So you want to present your answer in a way that convinces me that you understand what is happening here and you can explain yourself clearly. All right. I think that is enough in terms of examples for the first half of multiplication. It's not the whole multiplication. We do need to have a look at what happens if I can have any number first. Well, we haven't fully explored that. We're going to have to do that tomorrow. Are there any questions at this stage? I know fractions are just so soothing that there's a very high risk of falling asleep. They're just so comforting. Yeah, I know. I know. Their silence says everything. All right, then we will continue our discussion tomorrow. Undo it.